So P2-11 is going to take us into the spline. We don't use splines very often, but as far as a freeform curve and some different options for some unique shapes, it's good to know a little bit about the splines and what they do. So pretty much this is sort of elliptical, but not really elliptical. So um, the parabola, the conic, the ellipse, the partial ellipse, those all fall into the spline category. They are a series of points, and then the node points and calculations sort of drive that geometry. The other thing that they have is magnitude and direction at each of the nodes, depending on which spline style you've picked. In the olden days, there were parametric spines and Bezier. I think that's how you pronounce it anyway. It's been a while. Where uh, the the style spline in SolidWorks now has kind of a projection, a tangent projection, and you can drag those lines with it. I prefer the standard spline where we just get a node and we get the handles to drag and do that geometry. So it does say that it is symmetrical about the vertical axis. So we're pretty much going to draw all of this. And because of the complexity or perceived complexity of the part, I'm going to build the boss extrude, and then I'm going to cut this spline geometry out. Now we don't really have a side view to tell us if this is a boss or a through, but the assumption is it's a cut through the part. So if you wanted to do all of this in one sketch, you could. I think it's there's things that perceptually it's just easier to manage if you break it up into smaller pieces. So I've always kind of related it. Do you want a bite of wedding cake, or do you want to try to swallow the whole piece? So we're going to take bites of this cake and not go with all of the tiers. So I opened up a new part in metric. Again, we're just going to glance down here, and we're in millimeters, grams, and seconds. We're on the front plane, so left click, and then I click on the sketch. I would like to have my center line vertical and infinite length. Okay, and then usually I'll just select out of that because we can go back into the line command easy enough, and it's easier than backing out and trying to get to the as sketch. Somehow, whenever I've tried to back out of it and just click all of these off, I still end up with a construction line or something going on. So I just kind of jump right out. All right, so I'm going to start with the click drag, and we'll generate those geometry. And there's not a lot here to look for in the way of inferred relations. Just be aware there's a perpendicular, there's a collinear, and there's the vertical. And then we're going to bring that back a little bit. And in that case, we have the horizontal. We see the inference line going to the vertical, but it's in white, which means that it's not going to be assigned. So I can safely drop it. All right. My click drags, and I'm not doing a very good job of getting into the click habit. So if you prefer the click, go ahead and use it. So I know that these are not aligned. These should be collinear. So in the last video we had a relation, or the last couple of videos, I had a relation where I wanted to line up those points. So if I were to just take those two pieces of geometry between the points, I would get a vertical. If I go with a line and a point, I get a coincident. And if I go with the line and the line, I get a collinear. I'm going to go ahead and pick collinear. And most of the time, again, I'm going to pick the easiest target. Those object lines are a lot easier than grabbing a point, or at least I think I can grab those about as easy as anything. So we have half dimensions on everything. So since we're ready to start dimensions, 65, A lot of these internal dimensions are to the node points, so we have to kind of decipher these out. 20 millimeters for the angle, 30 millimeters for the depth, 30, and then 40 and 20 for the angle. So that should get us enough to get our sketches in place. So we're going to go between the object and the center line and keep it. It's going to switch to radial automatically, but I can hit the escape. And are there any? There's not really a dimension for the notch, so I'm going to say it lines up with that one. So let's go ahead. We have the 65. We'll go ahead and put the 40 and the 20, and we have 30 between, and then 40 for an overall. And let's see which one is going to cause me to go over defined. I guess not. We're going to go between the two objects and give it the 100, and that's going to stretch it out. So let's undo that just quickly. I'm going to show you that as this moves around, it's not uncommon for the sketch to overlap, have some different things going on. Try to pay attention to what it's doing, why it did it, and then it's a lot easier to correct for it. So I am out of the dimension though, so we want to go to smart dimensions. While we're here, let's go ahead. If you like the sketch numeric input, that will pop up the box and ask you to enter the value as long as you are placing the geometry. Replace, no, auto insert dimensions, and a couple of those you'll just have to tinker with and see if they work for you. So let's see, the 20, the 40, and we need a 30. All right, and then for this one, like I said, it doesn't really look like it's aligned to anything. If I do the hold the straight edge up, it's not really 20. It might be 10. So in the cases where there is a missing dimension, that is one that you get to decide. So I'm doing really good at getting those midpoints though. All right, so I'm going to go back and hit escape and reselect the line away from the midpoint. And then let's just go with a 15 and see how that looks. All right, pretty good. All right, another mirror. We're going to select from right to left because I want to include the center line so that when I hit mirror, it jumps right into the finished geometry. This is a 10 millimeter thickness, so extrude, and we're already at 10. I still like it to go the other way, so we've got that set up. Selecting the face that you want to sketch on. So any planar face is valid to sketch. And because if yours is not rotating into position, let's see, where was that at in the sketch? Auto rotate view normal to sketch plane on sketch relation. If yours isn't doing that, go into the options and check that box. So in this case, we're going to mirror the spline. I don't know that I need to have it be an infinite length. I could go either way on this one. It doesn't have to be. So we'll just put that in there. So we have the spline. The style spline, again, it kind of does an extension, and your handles are at the end of those extensions, and then an equation-driven curve you can put in algebraic or trigonometric functions and have it create from those equations. All right, so each time I click, I'm going to generate a node. And when I first started with splines, I always thought more node points is better. It gives you more control. Actually, it just creates more chaos. So we're given 1, 2, 3, 4, 5. And then either a double click or the select to get out of it. I'm better at the select than that one. So we're going to have to kind of figure out our dimensions here. We're going to be 5 millimeters from the edge, and then or from the center line, and we're going to those node points. So 15 millimeters, and then to the next is 20, and that one's up top on the left side. And then we have apparently a vertical for the 15, and a vertical. Yeah, I'm going to say those two are vertical. So if I hit escape and we go vertical between those two and vertical between those two. All right, so that gives us all of our um, horizontal dimensions. We're going to go back into the dimension command then, and we have 10 from the bottom. So let's zoom up on that a little bit. And then from the base, we're going up to 20. And you can kind of see the handles popping up. We want to stay away from those, at least initially. And we'll do another couple of spline examples while we're here to help define those. And then the top one is 70. And we'll go back to 20. All right, so that gets us fully defined, but this is still somewhat movable. So I said, be careful of the handles. Each one of these is going to control the magnitude of the curvature and the direction that you're working in. So I'm going to mirror. So select, control select the center line, hit the mirror, and then we want the lines to go in between. And then I'm going to go ahead and cut this. So features, extrude cut, and through all is what we've been using, so it will save it. And then let's go ahead and save this, P2-12. Get some initials in there for tracking. All right, so now optionally, let's take a look at if you want to tinker with the splines. So if you had an art project, you're going to 3D print something that's on the wavy side. Let's go with the regular spline first. Let's just take a look at the simplest spline, 2 points. And it's not really showing me vertical. Oh, actually 3 points. So as I drag those around, we're going to see them kind of invert on themselves, be able to loop. And then when I grab the handles at those different points, as I change the direction and the magnitude, then there are going to be places where it fails because it inverts on itself. So that one's going to give me an angle, and that one's going to give me the magnitude of the curvature. Because we're in spline, we have spline tools. So if I right click on the spline, show me the inflection points. Well, those are where it changes direction. Show me the curvature comb. No, it's here somewhere. Spline handles, display, minimum, curvature combs. All right, so this is how much curvature is that point. So there's a lot of, it's a very tight curvature there, and it gets more linear there. All right, so what I was going to start with on the spline then was if we just pick 2 points and escape, then we still have something that looks like a line, but I can make that line shift and change and do some interesting things. So as we move those endpoints and change those geometries, the rule is it can't self-intersect, is why it's stopping or it's failing to solve the sketch. All right, so the little handle is going to set the degrees, and the handle at the tip of the arrow is going to set the magnitude of the curvature. All right, and then the style spline, so the Bezier, 3 degree, 5 degrees, 7 degrees. Okay, I got some terminology I got to look up, but if we do the same thing, and let's just go ahead and, oh, maybe not. So as it goes through that process, we're going to get the construction lines, and that's going to provide the twist and or the curvature and the magnitude, kind of like the handles do. So it's going to be which one you prefer. I'm not sure about the 3, 5, and 7 levels. Let's go ahead and see what one of those does. So it must just be part of the calculation of how much control you're getting over it. And then the equation-driven spline, explicit parameters, y, x1, where you're going to put in your basically limits how the y equals your equation, and then what are the limits over what um, units are you going to display those. All right, so I'm going to leave the sketch up there, but since I don't want to see it, I'm going to clean up and hide it. Splines are fun, and they're kind of a limited use. It depends on the industry too. If we were designing in peller blades, we would probably be using the equations and a lot of that stuff much more. So it is a useful tool, and things like text or converting graphics pictures and kind of doing a light trace over a picture. That's one way to get the geometry into your model.